going on, everybody? It's back with Smiley's Garden and the Organic Takeover, and I'm really excited again to speak with someone I really look up to, and I'm always excited to see the stuff that you're learning and doing, Matt. But thanks for coming back on, Matt Powers, the permaculture student.
Thank you
Appreciate
for
it.
having me. I'm so excited to continue our conversation. I feel like last time I was like in this midstream point, and I've learned so much since we've last talked.
Sorry, yeah, man. That's what I was like. I've been, I follow you and watch the things you're doing, and it's like when you came out with that book, it was kind of, man, this guy really pieced everything together, and we talked about that the last time, but then within this last year, you had to be been working on some of this stuff with the microscopes, and I'm just excited, man, to hear about. Have you tell us a little bit about some of the things you got going on in our soil. That's the one I'm excited about.
Heck yeah. Yeah. Well, it's like when Chris Trump talked about this book, he said that this was a really I forget the word he used to describe it, but he said this is like a really good portal into a new way of thinking and understanding. And like what started happening to me was I started asking questions and being like, well, I'd have to test that. And then I like tested it. And then I was like, oh my gosh, EM is in all the hot compost, even the Johnson soup compost already. And like, wait, okay, what other tests can I do? And it became this like this because once you have the fluency of understanding the dynamics of like redox, the idea that energy can be gained and lost, that there's like a threshold for energy, but there's also this like bandwidth for like accepting like more and more energy through carbonaceous chains. And I want like for instance, like what is the difference between like biochar being digested by microbiology and other organic matter that we could call softer, or what I mean, and being digested? Because if we have microbial like all right, because I figured out that hyperdrive, because it's surfactant, can break the charge on biochar, and so EM can eat it. And because plants are essentially like glass, because light has to go in them and be absorbed, like every cell is like a little greenhouse. The black inside the bacteria that becomes endophytic, they put a force field around themselves, so they've still got that black carbon inside them. So I want to understand like the difference, like what happens like to the redox of the plant sap in relation to those differences, because that would be the place to look, right? Energetically speaking. So questions like that have like started to like cascade as all that because for me it was like creating the lenses that would allow us to actually see things properly, and I united all these things with regenerative soil. But then it was like that alignment, and that's a teacher thing. Alignment, we always align the question to like the way we ask it and what we've taught. And I feel like if we, like with this database, if we start doing things in front of each other and we start aligning them, they're like, well, what happens like in this bioregion when everyone's in this pH? They're like, oh, people in this pH range have this problem in our bioregion. And think, I'm thinking Sonoma County. I'm thinking like that fungal blight that jumps from the grapevines to the cannabis. You know what I mean? Like there's specific modalities and weaknesses and issues in every bioregion, but we'll be able to like actually see along that, and then measure all the other factors involved and be like, oh, well, it's a dip in this. And you know, so yeah, because we now have the ability to fluently go between these spaces, we're going to begin to iterate them out more and more as we develop. So what I also figured out is like the way we do assessments in biology, like Elaine Ingham stuff, that's just one way, because there's principles behind the way we do all experiments. And her way of testing is an experiment. She has a hypothesis and she's developed theories, and these tests are part of that. but the principles behind those tests are all the same. And so it's like time to like for us to all become, well, not you guys in the cannabis community. You guys are all citizen scientists already. Like that you guys elevated cultivation to a level of citizen science. Like, I don't know what year, honestly. I'm not that well educated on the literature, but I know it has to be over 25 years, maybe even 40. I don't know. You guys were on it.
You know, the bro science has been around for a long time, but a lot of that was trial and error too. You know, you do something and you see it works, you know, and I think I'd heard you say that about like Dr. Elaine, like people were trying to argue about this or that, and she's like, but it works, you know, like,
Right.
you know.
But that's how science starts so often. Remember with it was Einstein's theory that proved that we could make the nuclear bomb, but he said we'd never figure it out because you'd have to just like randomly try to figure it out. And so they literally said all these people randomly trying to do it until they figured it out. And he was like, ah, that was fast.
Yeah, and that's kind of the idea you're going for, right? Is that we get a bunch of people randomly trying to work out the little details and put it all together like puzzle pieces.
But isn't that already proven out in the cannabis community?
Yeah.
That model is totally proven out. I feel like like testing, sharing those test results and letting the consumer see that. If every industry did this overnight, we'd have better everything.
Yeah. Yeah, like vegetables and whatnot. Like,
Yeah.
because
Or even medicines.
I heard you kind of talking about that too, like a way to quantify, you know, nutrient density as a way of categorizing the vegetables, you know, like what's actually top grade, which is mid grade, you know, if it's based off appearance, that's, you know, that's not really giving us much, right? Like that's what we've been doing.
Right. Right. And so I've applied the same exact thinking that I did with the first book. And so I've gone to the mycologists, I've gone to all the different soil people to get a holistic testing array. And then I've also gone to the plant people. So bionutrient meter, a more sophisticated look at bricks, plant sap analysis, and plant tissue analysis. And I feel like, why don't we have trichome protocols? Why don't we have leaf protocols? Because I'm looking at these things and I can tell you like instantly, like when I turn this on, you know, on a leaf, like and that blue light begins, I can see, you can see, my children can see, I can teach any child to see the difference between the stomata that are not fungally inoculated and protected and the ones that are.
Hmm.
And so we can see inoculation rates. We also can see, because of James F. White's work, Dr. James White at Rutgers University, we can see the nitrogen fixers inside the trichomes. He always shares his stains. That's the amazing thing about him. He shares how he does it, the amount, the stains, and everything. And yeah, we're just. I mean, we don't have. And I mean, I think what we should do is we should apply what we do with the roots, and so we should do percentages. So you would count all the stomata that are there, and then you would just do that over, you know what I mean, the amount of highlighted ones over that, right, and create a ratio or a percentage. And so it's not really hard. It's just no one was looking. And what I also realized is that like there are a few people like in all the communities that have all these modalities and totally understand it. Like I was one of the people that's been following my stuff forever is like, oh yeah, with my polarizer, that's how I dealt difference between microfibers and fungi. And I'm like, you have a polarizer? He's like, oh yeah. And I'm like, oh my gosh, all right. And it's like everyone, they're embedded, they're quieter folk, they're really smart. And they're also really great at sharing. You know, this is a great community. And so setting the stage for that, I was writing this book. I was creating new protocols in microscopy that combined all these different things. And then I was like, oh, but I can't I can't leave it there. It can't just be like biology. You know what I mean? Like it has to be holistic. And so I was like, and then where are you going to put all this, Matt? And I'm like looking at all these hard drives. I'm currently trying to back up all my hard drives. We're entering day 9. Yeah, I know it's bad. It's been going all night and all day. I have so much like material, right? Like just from all the years, and then I back it all up. So, but a lot of these hard drives are ancient. They're like 12-year-old hard drives. So I've got to like be smart. But I asked a crowd of people that was coming to learn about microscopy here in Austin, Texas, and none of them had a system they felt comfortable with for managing the information they gather as they work on the microscope. And I was like, this is exactly my issue too. It's like I need to be able to not just have it organized, but to be able to like shuffle it and be like categories. Okay, cool. Date. I need to like be able to flex it. You know what I mean? And then also take things and just hold them up against other like have in revision image and then hold it up to like 50 other images of that. And in this database, because when we gather all that information, we'll be able to do that and gain fluency. But I think this is going to be just the beginning. I could see something exactly like this, but niche for cannabis.
Oh yeah.
Like an open source, transparent, open code. Because so many people in our communities are also coders. There's another thing I learned. They're like, oh, well, Matt, what are you really going to do? And I'm like, Mongo and Python. And they're like, okay, keep me in the loop. And I'm like, okay. So there's all these people that will want to make sure that this turns out right, which I'm not like the coder man. So I'm I've got a good team, but yeah, no, all the feedback, all that community feedback, all that refinement that we get from each other, it's going to set an example, I think. And we're going to see food. I think we're going to see lots of things start to be this open source, transparent, better, because this is the only way we get to good, better, best. I mean, that's how we did it with cannabis. It's like, if you don't expose the tests, if we're not like all have it in front, people are trying it, people are testing it, they're seeing the convergence of those things, there's no clarity. And so, yeah, I'm excited.
I'm too, man. And so I want to back it up a little bit because you said something that kind of, I guess, a fungally inoculated stomata. And I don't know, I
Yeah.
just want to, I'm curious, like, what kind of, can you identify the fungus? Because, like, Septoria has been on my tomatoes this year, and I'm curious as to if that would be a indicator, right? Like, you would look at the stomata of the leaf and see them not inoculated, or you would see the pathogen or whatever.
Yeah, that'd be really, I want to have those kind of references to go. I want to have diseased leaves as references for people so that we can differentiate. And I think it's going to be in the expression of the chlorophyll, and also the I think we're going to see a differentiation in color perhaps, or behavior. Because I mean, I see it everywhere in healthy plants. And we've had heat stress lately because it's like over 105 every day, but I haven't had any fungal anything. I mean, it's so dry here. So it's like that's not a common issue, I don't think, right now. But yeah, no, I want to see all that and hold that up. I don't have. That's the thing, though, is there's so few people that actually show their work. So this is the thing. One of the guys on the team is a microbiologist in another country, and I told him that they don't show their work because they don't want us to see how bad they are with microscopes or to second guess their research, because they just give us these little cute charts or these like fuzzy pictures, and it's like, you really can't operate a microscope. It's like they've got like no skill. And this guy like was quiet, and then he got angry, and he was like, I was always so frustrated. I wondered why they would like withhold the information, and now I know they didn't know what they were doing. And yeah, and he was like, he felt like he was ripped off. And so he was like, we are with you with this. This is going to be awesome. I'm going to be able to continue like my education as a coder. Like I'm going to be able to do coding and like and help with the database creation. But this in a way is like completing a part of him that was like denied. And I think that's like the case for a lot of things in the published journal, based world. I would say that James White's the exception. His papers read like manuals. He's like, I mean, that's part of it where I've learned so much is because I've been like reading through his things and then being like, hey, James, what about this? Could I do this? And he's like, yeah. And then I bring him the pictures and I'm like, is that? And he's like, yeah. And I'm like, this is amazing. And like that kind of feedback loop, though, is what everyone needs, to develop their fluency. And it's like when we have 50, 60, hundreds, thousands of examples and we rank them as a community. And so over time, you've got this very thorough system where the top 5-star, 4-star like ranking for the first 20 pages is all stellar. Then you could go like 40 pages deep and start finding like the 3 stars. And it's like, okay. And people could, I mean, we're going to have it so that people who are members can reinterpret people's pictures, and the better interpretations will get higher ratings, and then they'll be higher ranked. So it'll be educational. I really want people to like have that growth mindset where it's like, we're all learning, interpretation is an art. You know what I mean? It's not, I mean, that even the DNA testing, it's like that unclassified section, and then the human genes, it's like, okay, where are the mobile genetic elements? Show me the MGEs. Is it here? Is it there? Where do you classify it? Because they're not saying, oh, because they're in all of them. I see. You know what I mean? And so it's like they actually can't. They got to pick a place to put that. And so there is, we're at such an interesting place though, because of those uncertainties open up doors for actual like speed lanes. You know what I mean? It's like opens up completely, and we've seen it in cannabis. Like, how different is cannabis in the past 30 years? Like, oh my word. It's like
No, I mean cannabis gets tested more than like food at a hospital would, you know what I mean? So it's kind of crazy, but you're right. I mean, it's highly strict standards and realizations there for sure.
and it's because people really value it, and because the tests were in front of them so they could develop that value. I think the bionutrient meter, which is like a handheld spectrometer. I have it right there. Um, I think that we're going to see grocery stores have that, and they're going to put that below, the peaches, below, the watermelon, and people are going to be like, oh wow, look at look at the peaches this year, look at the cherries this year. This is incredible. I'm going to buy from these people.
Yeah, that's an interesting thing. Now, you said the DNA, and you did some DNA sequencing on like the EMs, right? Like a couple different
Yeah.
ones. I don't know, what did you learn from that? I guess was
So I have 2 types of EM. So I have Terraganics EM. And so that's like the EM row process standards. And then I have this EM extension that began over 20 years ago. And it was from the original workshops that EM was taught in North America.
and
And
EM
so
effective microorganism, just for real quick. Sorry, go ahead.
right. And that's a trademark term. So in other words, that's the term people use who are licensed when they sell it. So these microbes are not patented. They're not, and they're not trying to patent them or anything like that. I just want to be clear with that. It's just a word they use to sell it, and it's a word they want to protect. So that's what the EM with the trademark thing around it is. But it's yeast, it's beer yeast, baker's yeast, which is a yeast we selected, right? And so that like selected from where? Well, there, Saccharomyces cerevisiae is inside all of plants that we test, and then it's because remember we would put the bread on the windowsill to catch the yeasts. That means these things are in the air. So when we're aerating things and aerating compost, we're adding yeasts. And so yeasts are like just incredibly important. I mean, they're digesters of sugars. And so in a plant, because they're all endophytic, they're actually the way that they sop up extra sugars and help digest excess sugars and provide equilibrium in a plant.
In a plant. That's
so yeah. And so there's yeasts. And I can, and those are very easy to visualize and like visually verify on the microscope. But it's surprising how, and it's strange how fungal DNA resists breaking down. Like you can spend like 2 days breaking down bacteria and it will all sequence. But the fungi resists. And I've been talking to people about this, and they all are doing PCR. And that's like a delay pedal. And even when people are doing purified cultures of fungi and PCRing that, putting on the delay pedal, it's just, I worry about those results. I mean, I know people that had just pure fungi and it read as bacteria, which opens up like a completely other different world and door. And I now have like 10 other questions, right? But it's like, it's not a perfect science. Yeah. And this and the nanopore stuff that I have is the best because we don't have to create any replication. Because I mean, like, think about this for a second. If horizontal gene transfer is obviously happening all the time, and it's so fast. I mean, you've seen some of these things move. Some of these things move like meteors through our slides, and you're like, what was that? And then like you like get like really close and you see like they're conjugating, they're having sex, and they're like, and you're like, okay, that's really fast. It's like is that every time they do that, an exchange of DNA? Are they pulling DNA and inserting DNA that rapidly? And then as we are caustically attacking them, are they doing that as well? So in breaking down DNA, because fungi resists and different kinds of fungi resist more, that implies that perhaps there's even a hierarchy within the bacteria. And because horizontal gene transfer is the uptake of dead DNA of other things, it opens the question when we're DNA testing, is that actually happening to a certain like degree, like a 6% or an 8%? And then what's the proclivity? Because it's like E. coli that they bond so many of these things with, but it's a specific strain of E. coli that's their like proprietary one. And then they like isolate that out of your read. So it's like, it opens up all these like windows of uncertainty, right? But that's not how they present it. Like too much of science is presented like it's 1985 and it's like a press briefing, right? They're like, this just in, and it's like, no, that's not real. And you know what I mean? And it's like, and then there's a motive, like wrapped in that somehow. So it's like, I really value like the best practices. Because when I was an educator, that's what my master's degree was in. So it's kind of like a scrappy master's degree. You know what I mean? Like,
sorry, Matt. What do you mean when you were an educator? You're still...
when I was a public school educator. Okay, like so I'm a retired public school teacher. And so like when I was like full-time like educator. What did I say?
Cool teacher. I forget what we're. Oh man, I side railed that one. My
It's
bad.
okay. It's okay.
Take a drink. Um, no, the DNA stuff, you're right. And that's one thing that, like, I don't know, yeah, the more you dig into that process, like you said, they actually have to break that whole sequence down. And then there's like weird pairings, and then they kind of look at how, like you said, it has to break down to a certain point to be able to be sequenced. And that sequencing is looking for commonalities in that broken code.
Right, but PCRing, yeah, yeah. And so let me just say more to that. So PCRing is like bonding with these like blank half RNAs, you know what I mean? They've designated, and so they're splitting the DNA and trying to like create an echo chamber by cutting the DNA in half and then bonding it and sort of replicating it. It causes mutation. And so the whole thing with like PCRing and doing 400 cycles with blood is it creates anything. And that's why they took it off the, and that's why it's a faulty test. I mean, that's why the creator of PCR said it's non-diagnostic. And that's why it stopped being used. So it's a delay pedal. Think about it. You have how many samples in the blood? Like what else is in your blood, right? And then like with soil, it's the same deal, except like a million times more, right? Right. And so you're like putting a delay pedal on everything, and then you're like supposed to make a call from there. And because of like over fragmenting, having fungi read like bacteria, it opens up like a huge Pandora's box of like, hey, how can we track that? You know? And then like how can we like map the error rate for that? And everyone's like, oh, well, we can do that with the lumina. The lumina is the same thing. It's all, you know what I mean? Like error rates and the way that we create false positives is I think like a very human thing. Like creating blind spots, I think is very, very deeply human, because we're just trying to get things done as efficiently and quickly as possible because we got other things to do. And so, and that's honorable and noble, you know, in its place too, right? Maybe you got to go on a date with your wife, right?
Yeah.
But I really think that applying our thinking caps to like what we're doing when we do these tests that are like bundled, like, I mean, I've got this DNA sequence thing and it's like apply C1 fragment, and it's like a fragment. It's like 10 ULs of like, which is like a fragment of a drop of that substance. And it freaked me out. I called like William Padilla Brown probably like 60 times in like 3 days. And like he's so patient and kind, you know, and like he like was like, Matt, it's okay. You're gonna learn all about fractions of drops. It's gonna be wild. And then like after doing it like for a while, I was like, this is the craziest thing ever. It's like you become so hyper tuned into such small things. And we can like and I know I'm a microscope when I'm doing this, but like this is such small stuff. There's something about all this stuff, something about the way we work with plants that we're meant to, the way we work with fungi and biology, the way that like we're reinoculating our guts and finally reinoculating the plants microbiomes. There's something to all of this, and I want to map the gut biome of humans. I want to map the gut biome of ruminants, each one separately. Like, and because we harvest animals, we probably actually could do it properly, like open up the actual stomach, you know what I mean, of a goat, and then of a cow, and then you could actually, because they always do the manure, and I'm like, that's one that's part of it, but that's
Right.
not the part that I want to see. I want to see the stomach. I want to see the beginning, the initial, you know, and then, you know, and the intestines too, I guess. But yeah, I want to understand that map, because like the EM, this can be this is part of our digestion. This is for digestion. I was recommended this for my Crohn's. by Quatamuk.
Really?
And so this is also in all the good compost. It's also they're also endophytes. And so it feels like it feels like there's a lot of like plain truth that we're being just like tricked about. Like we're not like, and when we see it, we're like, oh yeah, of course. And it's so exciting because it's like a way that we're actually, I feel like we're liberating ourselves from this like fog that like I grew up in like a fog. It feels like this weird culture of like, keep your head down, don't ask too many questions. um you know what I mean? And it was just, today it's so different. You know, you do that, you die somewhere and no one notices.
It's crazy. It's a it yeah, like you talk about that. I mean, I remember learning in school like your digestion was all stomach acids and different things, and like now, yeah, we learn and we understand that our gut microbiome actually is our immune system, and like that's and that's the biggest role in keeping us healthy is that. And yeah, it's kind of mind blowing that change in perspective on it, I guess. It's like kind of, and I see that often though in the cannabis realm too, where there's that idea that all nutrients are the same. Nitrogen's nitrogen, phosphorus phosphorus, but then it's like that too. You start peeling that back a little bit, and it's like, well, yeah, I mean, at an elemental level they are the same, but not when you start talking about what charge state they're in. If it's a negative or a positive charge that's attached to, is it an oxygen or what? And those things aren't ever left alone out in the atmosphere, or out in the world. They're always going to be wanting to bond to stuff, and wanting to form higher molecules or whatever. So it's kind of an interesting thing on that too, where it's like, yeah, all that biology is deconstructing that, and the charge state is always like trying to bond stuff together too. It's kind of
Yeah, so thinking about that, I was listening to like the NPK University Harley guy talk about how higher salinity levels to a point like has like an incredible effect on terpenes. And I was thinking about the fact that like salinity is conductivity when we measure it. You know, we can flip it either way, we can express it either way. And then, I mean, like, so much of this stuff is crystalline when I'm looking at it in the right light, like in epifluorescence or the new technique, this light field technique that I figured out. Um, th- Everything looks like glass and it's crystalline. Even fungi glows, and this is the actual wavelength that is 2 to 3 inches deep that reaches the microbes. So the the fungal highway of the soil is actually glowing green. And so the microbes are riding along this green glowing highway, and along it are these crystals that glow. So it's truly incredible.
yeah, that's the whole idea, like the crystal and the electron, the amount of transfer that can happen of that power. But like I still like when talking about EC or conductivity like that, I still really like the way that like Olivier Poussin kind of portrayed it as like biological conductivity. And that kind of just gives such a paradigm shift in my head versus like, okay, because like if we're mixing up a fertilizer nutrient, we're watching EC. You know what I mean? I add this A potion and it went up to 500, and I add you know what I mean? And it's so that's kind of how they're gauging that mixture of that fertilizer too. But in my brain, that's still kind of a separate thing from that. But I know it's not really, but I don't know. I don't know how to grasp
Look up.
that. You know what I'm saying? Like, how do we grasp that idea that the biology is actually cycling nitrogen in a cycle, it's cycling potassium in a cycle, and we're trying to add a certain thing, a part of that cycle at a certain point to make it, and that shortcuts it all, what I mean? It like shorts out the whole cycle. We don't really know that, but it does, what I mean? It's like,
Right, right. And the crystalline shape and all that kind of the stuff I'm seeing, when we look at the definition of what a colloid is, it's a gel or like a liquid crystal. It's crystalline liquid. And so, and it hasn't hardened yet. So, and it can be really orderly structured too, or it can be chaotic. And so internally, I think that we're going to get to the point where we're examining the structure of things, just like when we look at like a leaf and we see the symmetry, we see like the color, like there's all these things that like our eyes recognize as like health, right? I think that there's actually going to be like the symmetry of the actual cells. We're going to be able to take snapshots, and then how much symmetry there is, we'll actually be able to understand the structure, and maybe we'll be able to go deeper. I mean, the thing with these microscopes is the resolution goes only to 1,000. I mean, and even then there's smaller things. I mean, like it's so crazy. Like I was reading about infrared microscopy, and they were like, well, we see the heat signature before we can see the microbes with a microscope. And I'm like, wait, they're there before they're there? How does that work? And it's just because they see little things, but there's things that are smaller. And everyone's like, oh, use electron microscopes. They're okay. Like they're not like they're not a magic bullet, that's for sure, especially when you got to spray everything down with gold and palladium. It's everything coated in metal. That's why everything looks so bizarre in electron. And there's different kinds of electron microscopes, but again, it's like these weird otherworldly things. And so we have to map them out. And and the other thing is, so much of this stuff is done with things that are so not pragmatic or not a good reference. I was talking to someone about like university science, and I was like, well, think about it. It's like, who manages those university ag fields? The undergrads. How long have they been farming? A year, a month, it's like, and then they go home in the summer. You know what I mean? So they don't get much experience. So keeping our thinking caps on, I think, is like the most critical thing right now in creating a place for discourse for the community to really learn and grow. And this program obviously is doing it too. I've seen so many examples like in my feed and just in the past week that I've wanted to just click on. But I've been doing this launch for the Kickstarter, but I'm also like unpacking. This is one of the rooms where it's like, it's a little boomy in here. I need to add things to it. There's nothing in this room really. But yeah, so
that is what it kind of amazes me about you, man. You keep pressing forward and keep kind of pushing that envelope a little further, And so one of the things I guess I had down, just random thought here, but like, I wonder if what have you learned about how the structure of the soil and the hydrology of that, where like the watering schedule, how that all kind of flows through, how much does that like dictate what the microbiome of that soil is going to be? Have you seen like a real staunch change in some of that, where if it's, I mean, obviously you're gonna, right? Compaction.
we would have to, because pH is directly related to moisture levels.
Okay.
Because the microbes and the plants are going to perform hydrolysis, and then they're going to be releasing those extra H's as protons, and that's going to reduce things and acidify things by nature, because pH measures protons, in hydroxide if you're above 7. So, so I mean, I'm really interested in trying this hydrolysis system. Have you heard of this? I have a unit right there in that bag. I'm gonna be trying it. They're like asking me to try it and showcase it. They're getting, I believe it's 275% increased in yields with their irrigation water, and they're cannabis growing. You know, it's a California thing. And so what they're doing is they're releasing brown gas and they're releasing oxygen and creating HHO, and they're changing the shape of the water, right? um and so yeah, it's just, I mean, it's something that like everyone could look up and know how to do hydrolysis. I mean, it's old, something we've all done in science class.
Just
But
running
I've never
electricity
messed
through
with
the
it.
water. Isn't that
What?
isn't that just running an electrical current through the water?
Yeah, yeah, yeah. And it's just, it's liberating things. I don't, I mean, I've met, I mean, this the alchemist, our Odin's alchemy. I'm about butchering his name, but Benjamin showed me his, and he had the ability to weld with his because they collected the the brown gas, and it
So what do you
allows you
mean
to
by
like,
brown gas? That's the hydrogen gas? Is that what you're talking about?
yeah,
Okay.
yeah. So it's a wild thing. So I'm gonna work with that, because I mean, if it's that healthy per plant, oh my word, it's gonna be amazing. But
So
I
it
want
would
to understand what's happening redox wise, because if it's
be
liberated all
adding,
the
right?
what?
It'd be adding energy, right? Like it would be like energizing the water.
Well, like, think about this: by adding all that oxygen, the reason it's do allowing for the plant to grow so much is because it's ripping off everything it touches and having more in the, like, more ions
In
in the moisture of the soil, in the field of the rhizosphere. It's really like, there's no word for it, but it's in the conductive range, really, is what I want to say. Like, it with humans, it's the proximal cognitive, like proximity. Like, we have this like range that we can like understand to. But with roots, I also, another thing that I want to be able to figure out and study is, it's like, uh, how can we measure how far our plants are reaching? Because they have a reach, right? And so, yeah, it's like I keep thinking about all these things, and in developing tests for them, only are going to come from. So I'm going to do as many of these tests as I can, but everyone's going to be like, out of 1,000 people, there's going to be two people who are going to go, Matt, have you thought about doing it that way though? And it's going to be like, unbelievable, unbelievable. So I really have faith that we are going to change all of soil science. I mean, already the things I've seen, and like, they point to a completely different paradigm for the way everything works. I mean, the fact that like 40% of everything's E. coli, the fact that there's like 40% of everything seems to, like, the soil profile seems to be unclassified DNA, which means it's influencing everything. So the heritage of time is always in the soil and always potentially genetically ready to express. And people are like, oh, how did these genetic species, these endangered species come back so quickly, and this and that? And I'm not saying like upper animals, large animals just kind of like manifest out of like a quick like horizontal gene transfer like miracle or anything. But like the fact that the fungi came out of nowhere that hadn't been seen for over 100 years, on the in Saudi Arabia with Neil Speckman's project at Al Beta, that's significant. And so the DNA is there, and it has effect. And again, it's like, we haven't mapped out the unclassified fragments and what their effects are on, because this is what I was talking about Jeff yesterday, Jeff Lowenfels, is it's like I want to be able to show that E. coli in pathogenic anaerobic conditions uptakes those genes to create pathogenicity. So I give you one strain of E. coli, and then out of that, I get the pathogenic E. coli. So that's what I want to do next, is get a purified one strain, because I mean it's actually quite easy to do. I mean the EM is 40% E. coli, just like everything else is. So and it's non-pathogenic E. coli. So I would just have to like, but that's the thing though, is there's the other controllers in that. So I have to get E. coli that's separate from all of that, that's pure. So I'm gonna go with some native soil because it's there too. But the idea is that I want to be able to prove that these things are uptaking it from the environment, and then I want to figure out how fast it's done. Because think about this, if it is done in 5 minutes, if it's done in 2 minutes or 30 seconds or 10 seconds or 5 seconds or even 6 hours, that gives us so much information. It's like, oh, you need anaerobic conditions for 6 hours for your E. coli to manifest as pathogenic. That changes a lot, right?
Yeah.
I mean, compost companies suddenly have like a cutoff point, right? It's like you stop, you turn that now, or like,
It's true though, yeah.
and if it's seconds, then it's like, oh wow, that's why or if it's like an hour, that's why like we have moisture meters suddenly at the bottom of all of our like plants, and they give us a reading. You know what I mean? And they eventually they come in built into the pots. Eventually, people are just like shoving them in their rows, like as like probes. And so we know, so that we don't, as we water, we stop, so we don't hit those potential break points that cause the windows for disease and pathogens to be created. Because think about this, our plants get attacked by these pathogens. That means the pathogens had to develop and get to large enough numbers first.
Yeah.
So there's this whole history of like leading up to that moment that could be easily mapped. I mean, we all kind of know that, right? We know the pathways, but it's like understanding the windows of time and understanding the thresholds for these things. So I really think the database is going to be such a great platform just for like housing all my work, because A, I don't have like a university. B, I don't trust journals. And C, I want everyone to see how I'm doing it in such a thorough way, because people, the way they communicate in science is so like truncated. It's like they're hiding so much of their work. And it's like, all right, so just an example, why aren't we linking the feedstocks to the time we compost, to the temperature we compost, to the end result microbes, and the DNA sequencing of like the original organic matter plant sap and the final compost? Because once we map those things, we figure out who digests what. And I want to DNA sequence the compost itself in like the hottest phase, because I want to see who's there. And so like having that full map for all the different feedstocks tells us as growers who to apply when, because then if we know who microbially is there in dominance, the top 10 in dominance, then you know which plant hormones they release. And I am of the mind that the foods that you feed these microbes is also what affects their plant hormone release. So we could be creating these brews, and then you could be finishing them off with like a flush of food, so that you're adding them and they're gassing off all this plant hormone for that specific time period. And then you could have this kind of universal compost or universal thing like EM or your own DIY biofertilizer. And then you could be tricking it out. And if you've done any fungal compost tea, you know that there's that sweet spot It's like 24 hours, maybe sometimes in this heat, like 6 hours, right? And there's this like window, and when you hit it, it's incredible. Like those kind of sweet spots exist everywhere. They're climate dependent sometimes. They're bioregionally dependent sometimes. Like like I know people in Sonoma County that have cannabis that is feral and is immune to all the different blights and fungal attacks that everyone else has in their area. And it's like those kind of genes could be just partnerships with microbes. And because those microbes are there, they're releasing hormones and other triggers that are allowing the plant to express that gene. And it could be in the soil because he's got good soil. And it could also be in the feedback loop of the seed inside the endophytes in the seed. There's a bunch of different pathways. But mapping those things out, I mean, like how many people are like mapping out the endophytes of the seeds? It's like,
Well, I think there's some attention to that because like disease can be carried there too, right? Like you can have disease go through seed
and
too.
that's the thing is we need to displace all the pathogens, or we need to trigger those pathogens to drop those genes and take up the right genes. And again, it's like there's so much stuff that we like we see that it works, and we've got good information about a lot of things. I mean, like that book is, I love that book.
I love what you were just talking about because it really kind of hits on the fact that the soil does have a memory, and there is like
Mm,
so a perpetual type use of a soil. So in like a pot, I don't throw that out and replace it. I just kind of dig out a portion to transplant into it, and but there would be a perpetual kind of a building of that memory, and that's what I've always heard from the idea is the soil is going to get better as it goes, and
yeah.
like the idea
Well,
is
if we even go back to how people talk about how weeds are actually cueing their successional cues. And so like what they're doing is they're actually pulling what's needed for that soil to develop from the air, from the water, from like the harder to unlock parts of the soil. And they're mining the soil, right? And so, and then when they die, they return those nutrients bonded to organic matter to create humus in the top layers. And so they're always trying to like do this service. And so that's a feedback loop of succession and repair. And so it's basically the way that an ecosystem learns.
that's crazy.
And yeah. And so when we are doing this properly with our soil, and I think Quadamuk V is an incredible example of this because he's taking all those stalks and he's making biochar, and he's taking all those leaves and he's making bokashi, and he's bringing bran, and he's doing all those different things. But the end product is he adds that back in, and adding that back in. I mean, I was talking to Benjamin about on Odin's Alchemy about this, and that's what alchemy is. And I'm like, alchemy sounds like nature. You know what I mean? Like, except for the whole salts part. I mean, like that sounds like chemical ag, which is so weird because chemical ag's totally, it came from alchemy. Um, so yeah, no, I think that we I lost my train of thought on that one. What
No,
was I
I mean
saying?
along that line though of like soil inoculation and like the idea that we're because you actually interviewed Chandler Jet House Gardens too. So
After watching yours, you
I'm
set
good
me up
friends
to
with
have a
him.
great interview. You
Yeah,
really set me up to have an awesome interview. Thank
he's an
you.
awesome dude, man. He really is. And we just actually he kind of Wormies GR and them hosted a just an impromptu kind of thing. And we got Leighton Morrison was out and we were talking soil biology, and the discussion came up about that, like, inoculation and like the actual, because organic Alexa's was there, and she's a learning the microscope, right? So she's been looking at a lot of samples, and that was one of the things they kind of started noticing, is that like the collections, no matter where you were putting the rice collection, they were seeing something similar. I mean, it wasn't like this whole different landscape of biology, even though there was totally different ecosystems they were grabbing that from, and then translating that into like trying to inoculate a soil. And is that, are you seeing that kind of same thing? And it was like, I don't know, under that idea of like the soil memory is going to overpower what you're trying to put there, right? Unless, I don't know, unless it was like completely scraped away and barren or something. But it's kind of, you get what I'm getting at? Like, are you
I think we
inoculating or are you
need,
biostimulating when you add an EM to that?
well, I think Chandler's question about whether it's the endophytes inside the rice that we're promoting, or whether it's actually indigenous fungi,
Yeah.
is an honest question, right? And I mean, in countries where this began, the rice was indigenous. And so it was for them. And so maybe if you have California rice in California, maybe you get Indian rice, and the wild, beautiful Indian rice that they like, they're hand taking out, because there's still Native American Indian tribes that are doing this by hand. That would have incredible microbiology on it. So I think that if that is true, there's still awesomeness to it. There's still validity to it. But I now realize that I want to set up an incubation tent, and I want to try two things. I want to do just a straight up incubation of the rice and see if the white hyphae forms on just a straight up incubation inside in a sterile environment. I think it's like a giant petri dish, maybe, pre-inoculated.
It does change the perception of what's actually going on there too, and that's just the thing about this too, that I've kind of come to realize. It's so fast moving, and there's so many different things going on. It's like when you try to zero in on one little spot, it's like this whole other city's still happening. You know what I mean? If you were like to zoom in from a satellite on New York, you could pick one corner of New York, in New York City, wherever, and you could see all this stuff that's happening, but there's still all the whole rest of the city still happening, and it's kind of always bigger than what we think of. So like sometimes you take one perspective and there's another perspective that kind of give you a different outcome.
That's totally how I feel about the database. I mean, it's the first time we'd be able to tell the temperature of the location that you're in. You'd be able to get an eagle's eye view. You could get an on the land view. You'd be able to get, you know what I mean? Like what it smells like. Like there's all these, like we're combining the senses to get an actual experience of what the soil is like for the first time in relation to what the actual end product is like. And that's been like the goal in the cannabis community, I think, the whole entire time. That's why I really give a lot of, I mean, all credit to like the people that have inspired me, because I wouldn't have thought of any of that if it wasn't already like out there, you know what I mean? And also something that I'm in awe of, and have been following this whole time. So I'm really, I mean, for me, I'm endlessly curious about all this stuff, because I don't know why. I guess that I'm obsessed. Like I'm hungry for it. Like I want to know why. And it's like they've misguided us for so long. And you know what? It's this. It's this. When Elaine Ingham finally got me to come face to face with my high school self and be like, Matt, you're not bad at science. Like that chemistry teacher made fun of your stutter. You were put in honors biology as a ninth grader, and you weren't ready. Like there were like reasons why you thought you sucked, and it's like, and this was years ago. It was like 8, 9 years ago, but she was like, "Listen, you can do this. You've got this," and it just, I don't know. Ever since then, I've been just like digging in, and it's so much fun. I was a kid that like read all the National Geographics, and my brothers. Okay, so as a kid, we didn't get our choices of anything. I grew up with three brothers, and my dad's a lieutenant naval officer. My mom's the daughter of the Rear Admiral of the Navy, and she's a politician. So like you could only watch sports or nature. That's it. And it was the 80s. So we had like click, 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 click. It's all like you got to mess with the bunny ears. Like that's reality. It's black and white. And like we had typewriters, you know what I mean? And so I didn't watch very much stuff. I actually didn't like sports. I like playing sports. I couldn't stand sitting and watching one. That seemed crazy to me. Like from a very young age, I thought that was weird. I was like, why are all these people like sitting around? Don't they want to go on the field? Yeah, so I like love nature and everything. I read all the National Geographic books and everything, and because that was like the only options that I had. And then when I wasn't being watched, I would like watch MTV. Like,
In living color.
yeah, exactly. Yeah, I was very influenced by that. Oh my word, that's a reveal.
It is. It is weird though, like the things that we become interested in, or what triggers. You know what I mean? Like triggers that interest. But have you ever dived down into the world of like aquatic microorganisms in that realm?
So I've been contacted by people who are into that, who are doing that, and they never sent me their samples. If you hear this, try again. But we moved, so you got to like contact me. But I'm interested in that because of the dual root zone example. So the hydroponics, straight up hydroponics, even straight up aquaculture hydroponics, didn't make sense to me given the science of what I've learned. Unless it's a plant that genetically has that in its past, then it makes sense, and I'm with you. But then the dual root zone came around, and that's Steve Reisner, right?
Yep. Yeah.
Yeah, so Steve will be at Myceliate, I believe, August 19th through 21st in Wilkinson, Washington, where I'll be a keynote speaker as well, which is so wild. I mean, like, I'm like a little nervous. I mean, he like figured out something like that solves a fundamental like issue for me because I have so many people that are like in the cities and they really want to be efficient with water and like Mike Garcia. You know Mike Garcia?
No, I don't.
He's LA pond maker. He's eco landscapes or something. I can't remember, but he's an award-winning landscaper and pond designer.
Nice.
And he's just always wanted to, I mean, his first design in the permaculture design course with me was is amazing like hydroponics microgreens operation. And I was like, that's not soil based, it's like it's not conducting the soil. And but the dual root zone opens up so much possibility. I mean, this allows for those operations to actually happen and for the nutrition to actually not hit a ceiling. And yes, there's still arguments about light, and anything with a pane of glass between the sun. But I think we're going to figure those things out.
Yeah, that's cool. I just kind of was jotting things down, but you had mentioned biochar, and there was one interesting thing I guess that I kind of realized about biochar is the idea of different feedstocks that you use in that can actually bring out a different. it's almost like snowflakes, right? Or what I guess is how I was picturing it, is they're all going to come out kind of a different structure or different, yeah, structure.
Yeah, so hemp would have probably the best structure because I mean they're using cannabis, any kind of cannabis, um, because that's what they're going to be using in semiconductors. And so I know that there's a special carbon structure to all cannabis plants. Um, so all right, so kelp is being turned into biochar and as a mineral amendment.
Really?
Yeah, which is I thought was fascinating when I read about it. And then most people want that hardwood, high temperature, holding water, sticking around. I can see it still here. But I think that there's like people in those studies where they're like, we added biochar and it disappeared in 6 months. I'm like, who ate it? What happened? Come on, let's get into it.
Yeah.
You know what I mean? Because it's like, it's like we're ruled by our eyes or something, right? We're like, look. And it's like, well, okay, well, what happened? You know what I mean? And we just stop at these headlines. But there's so much richness in digging a little deeper and asking more questions. And that's really, what I've been doing the past few years in all the different disciplines. That's what I did in permaculture. I was like, well, I wanted to read all Bill Mollison's original sources and I couldn't. They were all out of print. And then when I started getting into them, I was like, oh, this is old and not real. Okay. And so I had to update all that. And then I was like, I just started. So when my wife got cancer, it started this whole idea that I couldn't trust the things that I was like hearing from experts, like the doctor. So when they did the ablation of her thyroid, they walked in a suit with a container, and they opened the container and shuffled out, and there was another container in there, and then she, not wearing a suit, had to open it and then take the pill out of it and eat it. I don't know how my wife did that. Like to this day, I don't know what it is. I would have walked out and been like straight up.
Yeah.
I don't know how she did that. And maybe it's because she used to work at hospitals. I don't know. She used to work at New York Methodist. But 3 months later, she got cancer and it almost reached her lymph nodes. And so she almost was killed, in other words. And then when I brought it up, they couldn't look me in the eyes and everything. And so that messed me up and made me like really like have a hard time trusting people when I was I would and this is part of the reason why sometimes I can get like a little bit focused and a little bit argumentative or opinionated. I also come from a family where everyone argued. Third born. But yeah, no, and I was also a high school teacher, and so I understand like how inappropriate sometimes that can be, and also how worthless that can be, and actually helping people and helping yourself. And so, yeah, lots of growth. And so, yeah, and I'm really a product of a lot of things that happened to me, like at key different points in my life. Like I lost my birthday at around 8 or 9. I was in fifth grade. No, it was sixth grade. Because I apparently didn't. I told a lie to the neighbors about money that I overheard my parents say. I think it was personal business. I didn't understand what I was saying. I was a blabbermouth. And I lost my birthday, and they never gave me a friend birthday again. Like I never got one again. And then like I learned later, like my parents were going through it, and then they got divorced when I went away to college. But like truth, because they questioned my honesty, like, and then took it all away from me, and then like shelved me in a way, means like so much to me. If like people don't believe me, like Like I can be wrong, but like I'm not like lying to you. You know what I mean? Like I'm giving you like everything I can. Like I'm giving you everything I can. And so that though with science, you combine those two things and then it's like you can't go like the brakes on you is your ego. And so like traveling in humility is also in openness, like vulnerability is also like transparency. But that's like the fastest way to grow and the only way to know truth. You know what I mean? And like laying it all out there. And so and I also have the example of you all doing it. Like the cannabis community lives and dies by that. And so it's like I really value that. I really do. And so this database idea, and it's going to be I mean it's already funded, it's going to be open, it's going to be free, everyone can participate in it. The bricks bionutrient meter, if everyone plants all of that, they can all participate and add to this. um this is going to be the greatest good that I've ever done, because this is going to allow people to have honest answers. And then the people doing the right thing, regardless of who they are, regardless of whether I know them or not, or anyone knows them, is going to rise to the top. And because we're linking all those details of the feedstocks going in, how long, what were the temperatures, all of that, it's going to allow people to move with so much more speed and confidence, just like in the cannabis community that happens at like Chandler's compost camp. People are going to come out of there enthusiastic, engaged, just on fire with this stuff, and then with real skills and discernment, which I think, you know, having a skill to do something is one thing, but having discernment is infinitely greater, because then you can do something with that skill. Then you can differentiate, adapt, improvise, and push the ball further. So I'm really excited about what's going on in the world right now. What this Kickstarter and what it means, because I really think that we're like ready for this, and it's going to just blow the lid off so many things.
Absolutely. I will say, man, this when I heard the idea, it reminded me when I was an auto mechanic, and so with the advancements in engines, there was a lot of things inside the engine that were run by little electric motors, which
Hmm.
some of those would be really hard to diagnose if they had problems. But then we could actually read or measure the electrical wave signature of the amperage or volt, whatever. But you could get different signatures out of these electronics is the point. And we could take a snapshot of that. And there was an actual online database that we could go to. We could look up the year, make, model. Some of them weren't there, some of them were. You know what I mean? And then you look up the component, and it would have known good and known bad signals there, and you could quickly look at what you had and determine if it was a known good, okay, and move on. Or you could see, yeah, this is that same glitch. Boom, there's the problem. But that database was like priceless for that, because without it, you couldn't physically take that little snapshot, and you couldn't recognize if it was good or bad without seeing the good or bad before, so like if it was a new car or new something to you, you could always reference back to that. And I see that, so this that possibility with the soil, our soil, as it's building, there's going to be that opportunity to be like, man, I can compare what I'm seeing here to what other guys have seen across where, the world, probably, right? Like,
Yeah, and there's so much to this. So I learned recently, and I have a polarized lens here, but you can actually calibrate if you have a reference. You can calibrate to actual degrees, and it tells you the mineral that's fluorescing. So you can go through like an actual initialize.
you grab a drink if you need.
Yeah, hold on one second.
Yeah, you're fine. Like, say hi to chat. What's going on, everybody? Hope you guys are having fun. I know we dove in real deep, real fast.
Woo. Mm. All right. Say it again. Whew.
We were talking about that database and being able to reference like good and bad type things.
Yeah, I mean, the ability to actually have references from minerals, because it's a certain degree that these things fluoresce. And so, and it's a color. And so if you know the nanometer thickness of your sample slide, and I'm going to have between 20 and 30 nanometer deep slides, which is like really good because it's super easy to read. And you just go along this color bandwidth. And so you're like, oh, wow, it's this color. And then you're like, oh, that's quartz. Oh, that's feldspar. Holy cow, we have so much sodium in here. And then we're very soon going to be able to automate the ability to like click, 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 click. Boom, it reads it. And just like Minecraft, it calculates it for you. And so just point and click for like those things. And then it tells you like, oh, wow, you got like way too much sodium.
Hmm.
And you didn't need to do a mineral test. It's a visual test. And so there's all these references. There's so many ways of doing this. And it's never been done before, which is the most shocking part to me, that that people are doing bricks, but they're not doing organic matter in alignment with bricks. And then I was talking to Jeff Lowenfels, who's like, they've got a database. It's fungal to bacterial ratios with pH. They've done it. And I'm like, I want that database. Yes. I'll take the information. Yes. But that's not it. We need the bionutrient meter, the bricks, the plant sap analysis, plant tissue. We need the mineral test, the paramagnetic, the redox, the pH, the micronutrient, macronutrient. Like we need the biology, because that holistic picture has actually never been done. I mean, people are doing it. No, I've never seen it done. I mean, John Kemp is doing mineral tests on the soil and doing plant sap analysis. And that's what inspired me to start thinking this way. But he's not doing holistic tests on both ends. And so doing holistic assessments on both ends to create like a 3D picture and then putting them together, never been done. And the fact is, it's never been done, and then never been done transparently, like across like bioregions and then across like plant types. It's going to open up so much information. We're going to find out like, oh, well, if you're adding nitrogen, you have to be careful about this, or it can go south, or because your plant doesn't process the nitrogen properly. And so it's always best practice to pre-digest it at least 40 to 50% before you add it, so that it's amino acids and the nitrates or ammonium or whatever, you know what I mean? Um, but we don't know that yet, you know? So so these kinds of things are going to come to the surface.
It doesn't really surprise me that these aren't things that have been done, just because, like,
Mm.
I don't know, like if you go back, you've probably read and or at least seen Dr. Elaine's initial study, and I can't think of what that was, but it was like biology and plants, and but she has like actual like measurements in there of like fungal and the amount of fungal ratio to bacterial ratio and the actual effect that had on the growth of the plant, and like
But
graphing
which
out stuff.
fungi, which
Well,
bacteria? That's
right,
the problem
but
with
what I'm
that.
getting at is like that was what 40 years ago. You know what I'm saying?
Right.
And it got almost like tabled, right? And she's had a lot of
Mhm.
controversy, and a lot of that information was kind of like, but imagine though if we had if that really had gotten out there further, or like it is now. I mean, how much further that would advance if people would really get on that bandwagon of like, yeah, this is she was on to something, you know what I mean? And I think that wave is really catching now, and like the whole idea of the endophytes and like the rhizophagy cycle is just freaking mind bending. I mean, it really is. That just blows your mind. That my mind anyway. That plants are actually eating these. They're taking in these bacteria and they're stripping the nutrients out of them and they're kicking them back out. You know what I mean? And they're farming these things. So some of that stuff is like, it doesn't surprise me that there's not that database yet, just because it's so counter of what everything thoughts are on everything now, you know.
Did you catch that interview with James White where he talked about Darwin, Charles Darwin?
I didn't.
So Charles Darwin was obsessed with roots, plant roots and earthworms, and he thought that there was like a root brain in the roots, and I mean that's essentially like, you know, part of this whole idea that there's this like this that there's much more than just you know, something reaching for water, or you know what I mean, or I mean, there's something there that is akin to a Spitzenkorper, like the way that like the forces are coming in and going out all at once. I mean, 80 to 90% of exudation is reabsorbed.
Wow.
So it's not quite cakes and cookies, unless you're Hansel and Gretel and it's the witch,
Oh,
right?
yeah.
Because it's getting those microbes fat and then like bringing them in and harvesting a lot of them.
And now, what are your thoughts on like those ex or no, I guess I didn't realize that they were taking that back in, and
Yeah.
what I was trying to get at is there's this idea that chains of carbon can actually carry information, right? Like
Mm-hmm.
it can be a carrier for information, and that's kind of what the cakes and cookies were, is that communication in a way, you know. But that kind of even
Well, let's talk about that. Let's break that apart. So this is something I talk about in my class. So the Rhizosphere book, second edition, came out right as Regenerative Soil Kickstarter like happened, and so I was like, I'm gonna like buy this really expensive book. And so like I opened it up, and like the first chapter is like, when this began 20 years ago, or like when I began studying this 20 years ago, I had high hopes. And now I realize that we really don't know much. And I'm like, oh, snap. And they're like, and they go in hard and they're like, well, 80 to 90% of exudation is reabsorbed. It's like a shotgun blast and has mostly no effect other than like if the microbes are there and they're growing in it. And so this is the thing though, is they're putting it out in these examples that they have in the lab, and it's putting these exudates out and it's getting reabsorbed and it has little to no effect. Only when there's microbes in a living soil are we getting this rhizophagy thing happening. The roots, hairs are coming out, because if you don't have biology, you don't have root hairs. And so it's it's really wild. Um, if we think about like the fact that they're putting out all of that, it's a lot of sugars, and if they didn't reabsorb it, it would be a huge loss. And it's like fishing, and so they put out this exudation like a shotgun blast until they have the microbes coming in, and those microbes, as they stress out and as they're being killed, are all dropping what they're holding. They're all showing like their endophytic quality, so they're fixing nitrogen. And this process is they release them like the ones that don't fully die. Like, sorry, so there's like three stages. So there's ones that just are straight up dying. There's others that they lose their actual membranes, their outer shell. They become protoplasm, so these blobs, and then they reform their membranes and they get pushed out through the root hairs. And then there's endophytes that are fully like covered in their force fields, and they're fixing nitrogen to stay in place. And so that and then at the tip it's really acidic, and then as you go progressively back it's more and more alkaline, and at the tip it's the most like reduced, and then as you go back it's more oxidized. So as they push out those microbes and they have their little halo around the tip of the root hair, they have progressively more and more alkaline expressions of exudation and more oxidized. So you've got this gradient of nutrient exchange happening, because they're also, I mean, protons are being released as well. And so you've got this gradient of pH, this gradient of redox, um, and these the exudation really is a way of creating like a setting where things can happen. And so when those microbes come in, they could be releasing the hormones that trigger something that's a response. I mean, that's what mycorrhizae does, right? That's what rhizobia does. They're sending in something. With rhizobia, it's an infection thread, or infection hair, and they're going in there and they're triggering the plant to have a response, and the plant's sending sugars, in the case of rhizobia, sugars in the case of mycorrhizae, but there's other things that they do as well. But it triggers these responses immunologically, and it allows them to enter and then do their thing. So with rhizobia, they swell they swell that root hair into a nodule, but they have to come in endophytically first. And so they make it right through the rhizophagy process. And then mycorrhizae literally just comes in and starts wrapping around the cells and then going in between the cell wall and the cytoplasm inside the cell, if it's endo versus ecto. But they're hijacking the same processes. So only does the signaling begin like at that point between them. So it's like they're initially brought in through a generalized pathway, and then only in response to the plant's like open sign and their like open living room, that, or like a reception area that people are walking into, do they actually interact with them. And there are rhizobacteria that are on the root level that are releasing things. But again, like, it's hard to measure that like in happening in situ in real time. That's the thing. It's like we're doing this and we're doing it in petri dishes, we're doing it in slides and everything, but I want to see a lot more of this stuff. And I think that in our community, we're going to have really creative, I mean, the things that I've come up with test wise that seem novel and new and everything. I think that once we get the idea that like we create new test methods to test new things to get a better idea of what we're doing, it's going to go viral, and we're going to have so many more and much more interesting insights like very quickly.
I hope so, man. Well, hey, Matt, I mean, we're about an hour and a half in here, and I think we've covered quite a bit. I got my notepad full of notes here. I know that. I hope everybody listening does too, man. And I really do appreciate the work you do and just the passion that you have to continually kind of feed that curiosity. You know what I mean? Like
Yeah.
I think, how many years have you been on the like YouTube? I know it's at least 6. I thought I saw on your channel. I went back, but
I don't know. The funny thing was I started off with like recipes. So I started, and I've had other YouTube channels before that. I had music channels. None of them got more than like 100 subscribers.
permaculture student has been, I
Yeah.
mean, at least 5, 6 years now, right?
Yeah.
That's great, man. Is there I know the guys have been posting that in the links in chat, but I mean, if you want a quick kind of shout out any links or anything that people, or how they can find out about the Our Soil database?
Yeah, absolutely. The Kickstarter has 3 days left. In the morning at 8 a.m. It'll be 2 days and change left. And it's a Kickstarter. So it's gonna be all my backers that are going to help can co-create the database. And we're gonna be meeting monthly. I'm gonna be having polls. It's gonna be open source code. We're gonna beta test it together. So I get your feedback. And when we meet monthly, you can hop on the video or the audio if you don't want to show yourself. But that feedback loop is how I, as an educator, calibrate always. That's why I have these courses, and that's why I create new editions and everything, because as I see how people learn and in the areas where either they struggle or areas where they thrive, I adapt what I'm doing. So there's this Kickstarter, and it's I don't know where we are right now. I think we're at 201% funded. It's going to happen. But if you want to take part in it, be part of the membership, be part of the creation process. And there's also going to be a microscopy course. And it's actually the second book in the Regenerative Soil trilogy. So it's going to be Regenerative Soil Microscopy. And it combines mycology and biology and the soil food web ways of thinking, but it combines it all in a new way, new methodologies, new tests. And it's not just bright field, which is what everyone's traditionally learned. It's dark field, it's epifluorescence, it's polarized, and it's this new technique that I'm pioneering right now called light field. So different from the light field microscope patented like thing. It's I might rename it, but you'll understand. I'm going to reveal really soon what it is, because once my students start doing it, everyone's going to see how to do it, and it's going to go viral. The crazy thing is, I feel like microscopy folks have never had like photography roommates. I hadn't like old timey, like, those accordion cameras when you had like the actual like block and back that you turn, flip, and you only had two pictures. That was my roommate, and he was in a dark room all the time and everything. And I realized we were doing like microscopy upside down, and we're doing things backwards in so many ways. And so visually, there's like a whole new frontier opening up. And so that's what the book is, that's what the course is. And together we have the skills and the fluency and the way to document things that we've never had before because of these tests. And also microscopy has just gotten so incredible. The epifluorescence through LED, not the mercury vapor lamps of the past. And I don't know of any other LED systems other than this and the kits that we're going to be making for folks with bright field. So everyone can get involved. The reality is fungi glows, and the activity of fungi is this very distinct glow. And like with this light on, you can instantly diagnose roots or leaves. I mean, it's not hard. Like, that's the most incredible thing about this, is once something gets pointed out, our fluency with our eyes and our pattern recognition with our eyes as humans is incredible. And so you just pick it up. And I think that's part of what's so addictive about it, is because my pattern literacy loves it. I mean, some people do puzzles, some people do, you know what I mean?
Yeah.
For me, I just get drawn in, and then because it's behavioral, and then there's like cycles involved, and then because like redox, right, and pH, and like there's all these different influences on the behaviors and the systems involved. I just get drawn into it. And so this Kickstarter is for the database that's going to be open and transparent, and also the information on how to navigate and add to it and contribute to it. So it's never been done before. And if you just look up regenerative soil or regenerative soil microscopy on Kickstarter, you'll be able to find me. There's 3 days left, and we'd love for you to join us.
That's amazing, man. Well, thanks again, dude. I really appreciate this time that you spent with us, and it's always just such a riveting conversation with you because there's always so many new things that can go down. So I hope everybody in chat gets a chance to make it over, check out his YouTube, and follow along in the Kickstarter program. And yeah, man, I appreciate this time. So I'm